Hello everyone and welcome back to the video. In the last class we have discussed about the mass balance. In this video we are going to talk about the moisture content. Why this is really important means the students which are going to appear in patent examination and gate examination and many other examination. This moisture content question is really important. Even in the FSSI CBT, in 2009 written examination they have asked this question. So that's how the important question is in the moisture content, and we are going to learn all about it in the easiest and simplest way. So if you like the video, make sure to subscribe and share it to your friends. So let's get into the video. So moisture content. Okay. So the term moisture content means what? It's an amount of water. Okay, it's an amount of water present in a moisture sample. Simple. See, moisture content means amount of water present, and we have two bases. One is the wet basis and another one is the dry basis. I'll let you know why this difference is there. Okay, so first this one is amount of moisture or amount of, let's say, water is present in the per unit of mass of wet sample. Here same amount of water present in the per unit of mass of dry sample. See, if you are taking a dry sample which is like a bone dry condition, then the moisture content which you are going to see is very low. Then you cannot use the standard procedure which you are using for the wet basis. In the wet basis, the whole thing is actually a wet sample. Okay, but here it is a dry sample, so the concentration here is different. So you need a separate standards to measure it. Why it is so? I'm explain this in a simpler way. To understand this, if I have to calculate the moisture content of wet basis, how I should calculate is actually I need to know the water, right? So amount of water I need to know. So mass of water, and what I'm going to divide is the mass of the moisture sample, right? See, if the water is present in the moisture sample, then it is mass of water divided by the mass of moisture sample. So for the dry basis, it's actually mass of water same divided by the mass of the dry sample or dry solids. I'll say dry solids. Okay, so this is the equation. See, here I'm checking the water in the moisture sample, here I'm checking the water in the dry sample. So if you actually combine this both of the things, you will get to if you make a relation out of it, you will get a formula of moisture content of wet basis, which is equal to moisture content of dry basis divided by moisture content of dry basis plus 1. See how this equation came. It's a big step which you don't need to know if you are attending for some problems. You need to know the formula only. So I am not going to deep into how this equation has been made, but you need to know the formula. So if the wet basis is the question, then in dry basis the plus will come. So reverse this equation, exactly reverse this equation. Moisture content of dry basis is equal to moisture content of wet basis 1 minus moisture content of wet basis. So if the wet is there, it's minus. If the dry is there, it is plus. Okay, so it's actually a reverse of everything. That's it. So this is the two equation, but there is one more equation you need to know. Okay, that equation is the combination of these two along with these two. Okay, see why I have told you you have to combine this. In some question they will directly give you this like wet basis, dry basis, moisture. In some question they will give you the mass of the moisture sample, mass of the dry sample. Then what you will do, you cannot calculate it like that. So that's why there is a simple step is there. If you follow the simple steps, it will be easy. Okay, remember this step. You have to study this also, but I'll let you know how to actually derive this so that it will be easy for you. Let's take this as an example. I'll take this dry basis as an example. Moisture content of dry basis. I am taking the whole equation here. 1 minus moisture content of wet basis is equal to moisture content of wet basis, right? You get this equation, right? So let's say this is the equation. Okay, now what happens is, see, I have two things. Keep this as same, apply this formula, apply this one, this I'll put this as a 1, I'll put this as 2. So apply this, mass of water, this is dry, right? So mass of dry solids into 1 minus moisture content of wet basis is equal to, this is mass of water divided by mass of wet sample. So see, simply I can divide this, I can cancel out this one. So 1 minus moisture content of wet basis, which is equal to let's bring this equation to the top. It is actually mass of dry solutes divided by the mass of wet sample. So if I bring this equation here, then it's actually, if I bring this here, 1 minus mass of dry solution divided by mass of wet sample, and here it is dry solution, is equal to moisture content of wet basis. So now you get the how we have to apply that equation, right? Same way you can apply this in the first equation also. Okay, why it is important? See, if in case in any question they haven't given you the dry basis, they have only given the wet basis, but you know how much of dry sample is there, then you can follow this equation. Means, see, here you have wet basis, you have dry sample, you can follow this. If in case they have given you the other way, if they have given the dry basis but they have forget to give you the wet basis, then you cannot follow this one, you have to follow the other formula. So you can derive this. Actually we are basically applying this in the equations here. That's it. Now you have understood all the things you need to know about solving the problems in the wet basis and dry basis. Now let's solve the problems. Okay, so first question, convert a moisture content of 85% wet basis into moisture content of dry basis. It's a pretty simple question. I have wet basis, I have need to convert it into dry basis. So moisture content of dry basis is equal to moisture content of wet basis 1 minus moisture content of wet basis, because wet basis is given, which is 85, so 0.85, 1 minus 0.85, 85% means 85 divided by 100, right? So I am putting 0.85. So if I solve this, I'll get 5.67. Okay, simple. So what, but I need to convert it into moisture, like percentage, because they have asked as a percentage. So this 5.67, if I convert it into percentage, it's actually 567%. So 85% of wet basis, in dry basis it's actually 567%. So let's solve some difficult questions. So in this question, you can see the potato flakes are involved and the potato flakes are being dried. So it's a dryer. and the potato feed is actually given with the moisture content of 75% weight basis. Okay, and the moisture content of air entering, actually they have a dry air to remove the moisture, and the dry air is actually 100 kg per hour. But along with the dry air, there is a little moisture present along with the air, which is 0.08, which is mentioned here. Moisture content of the air entering the dry air is 0.08, and the moisture content of air leaving is actually gained some moisture from the potato to the dry air. It's actually gained some moisture from 0.08 to 0.18. Okay, and the moisture content is obviously going to be reduced in the potato also. They are asking how much is reduced. Okay, now this is the question. Now let's solve the question. Okay, sorry, actually they haven't asked the how much of moisture is actually present. They have asked the product's moisture content. Okay, so since they have given moisture content in the feed, they are asking moisture content in the end. Actually, in this question, even though the question is related to moisture content, this is also related to mass balance. Why? Because even though moisture is removed, that means some mass has been removed. So that's why we have to check the mass balance also. So the first step in solving a problem is to draw the whole structure, right? So that step is already been solved. But suppose if they haven't even give you this diagram, then you can draw yourself, right? This is not that hard at all. So the first step is done. What is the second step which I have told you usually? It is to check the total mass balance. So let's do that step. Okay, mass balance. Inlet I plus F, which is equal to E plus P. So we know I is actually 50 kg plus F. F is what? I mean I is actually the inlet air, F is the 50 kg potato, and E is the exit air, P is the product, right? So we need to know what is the I and E. You might have said that okay, 100 kg is the answer, right? No. Along with the 100 kg, 0.08 moisture is there, because this 100 kg is a dry air, which means it has no moisture. If the moisture is there, it's an extra. It's not coming along with the air. It's an extra. Okay, that means we need to calculate that first. So let's say mass of the air, let's say entering. Okay, mass of the air entering, and I can say I is equal to mass of the dry air plus mass of water present in the air. Because see, mass of the dry air is 100 kg they have given, but along with that they have also given the moisture content. So the mass of the dry air is 100, but in that 100, along with that 100, 0.08 moisture content is also there. That means it's actually 108 it's 108 kg of air is there. That's the inlet. So same we can check for outlet also. Mass of the air in the outlet. So here you can see 0.08 moisture is there. See, the dry air is going to be same in both the cases. Mass of the dry air, only the moisture content has been increased by absorbing the potato's moisture, right? Mass of the water present in the air. Okay, so the mass of the dry air is actually same 100 only, but it's gained some moisture, which is 0.018. So 0.18, so it's actually 118 kg. Now you got some values, apply these values in the equation number 1. So 108, okay, plus it's 50, so 50, which is equal to 118 plus the product. So what is the product value? It is actually 40 kg per hour. Okay, you have find out the product value is actually 40 kg per hour, but we need to calculate the moisture content. If you need to calculate the moisture content, you have to use this moisture content first. In this question, moisture content is given 75% with basis. Let's take advantage of that point. Let's do the second step which we used to do, third step which we used to do. What is that? That is the solid mass balance. Solid mass balance which we used to do, right? We'll do the same step. Okay, so actually 50 kg of potatoes there, right? 50 kg of potatoes there. Here wet basis is given, means it is moisture. The opposite of this is the solid. So if 25% is wet basis, then 25%, 75% is wet basis, then 0.25 is a solid. So 50 into 0.25 is equal to, I just know the product product is 40. Along with that, how much of percentage of solid is there, that I don't know. I'll put as X. Plus air doesn't have any even though I know the value is actually 118, and here is also I have something like 108, but there is no like solids in there, right? So that's why I have removed the air. Only this we need to calculate, so we can get the X out of it. X is the dry solids, and its value is actually 0.3125. Now do the reverse engineering. See, 75% of wet basis, we have said that 0.25 is the solid present in it. If 0.3125 is a solid, then how to convert it into wet basis? It's actually simple. 1 minus 0.3125, which is actually 0.6875. So actually it's 68.75% of wet basis. Simple. So now we got the wet basis of the product. It's actually 68.75%. It's 68.75%. But we cannot stop there, because the question is, they are asking that calculate the following. Actually, they are asking in the dry basis also. They might ask the dry basis also. So let's calculate for the dry basis also. So if you want to calculate for dry basis, it's actually 1 minus 0.6875 divided by 1 minus 0.6875, and it will come around 2.2 kg. So that's it. This is the moisture content of dry basis, and you have moisture content of wet basis also. Now you have solved the question. Done. Now let's solve the question which is asked in the patent examination. Okay, so the previous year patent exam has this question. So let's solve this question. Actually, it's a pretty simple question. The first part of the question which we have already discussed in the video. Now let's discuss the second question. So how to do it? First, we know we have to draw the first step is to draw the question, right? So it's simple. Wet products has 70% of water. Okay, there is a wet food product is there. Food product is there, which has 70% of water in it. Okay, and after drying, so the system is actually doing the process of drying. It's found that 80% of original water has been removed. Actually, from the 70% of water, they have removed 80% of water. Means the product has 70, which means 70 divided by 100 is there. Percentage of water is there. From that 70, they have removed 80%. Okay, so it's actually 70 divided by 100 into 80 divided by 100. So if I solve this, I'll get 0.56. So it's actually 56%. So the water which is removed is actually 56%. 56% of water removed. Okay, so, and I have a product also, but I don't know anything about the product. Still, I don't know anything about the product, how much of water is present, or we don't know anything. And they are asking the mass of the water removed per kilogram of wet food. So they are asking how much water is removed. They are asking in a value, and composition of the dried food. So they are asking this value also. So this is the question. They're asking this and this. See, they have mass of the water removed per kilogram. That means I have to take 1 kg as an example to solve all this. Okay, I cannot simply use the values, right? I have to assume some value, so that value is actually 1 kg. Now let's solve the question. So what is the second step? Second step is to do a mass balance. It's a simple solution. Okay, what is a mass balance here? I have 1 kg of the product. See, here I cannot do the mass balance because the only mass which I have assumed is 1 kg, but I have water content. So I am doing the mass balance of water, not the solutes. It's a reverse thing because here all the things which is mentioned is water, not the solutes. So I'm going to take the priority of the water here. So 1 kg of product into 70 divided by 100 is equal to water removed is 56, right? So it's actually 56 divided by 100 plus the product. I don't know anything. So product water content, I have no idea what it is. So it's simply product water content. So if I solve this, I'll get it is actually 0.7, which is equal to 0.56. It's equal to product. So yeah, plus 0.56. So this, if I bring this value here, it is P is equal to 0.14. So now I know the product of like water content here, 0.14. But I need to know the solids. See, this 56 is already we have solved the first part of the question. Amount of water mass is removed. It's 56% only. But I need to know the composition of the dried food also. In the product, how much? If the water is actually 0.14, then what is a solid? So to understand this, I have to look to this product. See, we know the mass will never change. If you are giving a solid of 1 kg, you will get 1 kg out of it. Solids. Because in this, if it is a solid plus water, the water might evaporate. But if it is a dry solid, both the 1 kg you will get the 1 kg out of it, because mass can be neither be created nor be destroyed, right? If that is true, then just look at the product section. In the product section, 70% of moisture is there, which means remaining 30% is the dry solid. So 30% of 1 kg is what? 30 divided by 100 into 1 kg. This is actually 0.3 kg. So 0.3 kg is the solids which is present in the inlet side, which definitely be same as the outlet, right? So outlet is also same. So the outlet's product is also 0.38. So that's it. That's the question, and we have solved it. It's a simple question. Now let's solve the next question. I'll explain the energy balance in the next question. I'm going to talk about a new question here. Here. A membrane separation system is used to concentrate the total solids in a liquid food from 10 to 30%. The concentration is accomplished in 2 stages. First stage, the 10% is actually reduced to 25% of total solids. Okay, here it's mentioned here. And what happens is there is a wastage of 0.5% of total solids. And along with that, we have also known that we are recycling 2% of total solids. Okay, so this is a 2-stage process. See, I told you if it is a 2-stage process, if it is going inside it, you don't need to practically consider anything what is happening inside, right? Amish, whatever I'm telling you is right? So only thing is whatever is going inside and whatever is coming outside is the main concern, and whatever it is cutting the outer part is the total. We have to consider that in the total mass balance. So if I write a mass balance for this specific one, which is F, is equal to W plus P. Am I right? F is equal to W plus P because that is the one which is cutting the border. The rest of the things is accumulating. So that's the question. Okay, so now let's apply some of the factors which we know. What are the things which we know is actually output product is actually 100 kg. Just given here, the product should produce 100 kg of 30% of TS, which means F is equal to W plus 100. Okay, let's do a solid mass balance. If I do a mass balance, it is actually 10 divided by 100 plus F, which is equal to waste. We don't know how much waste is there. It's actually 0.5. 0.5 divided by 100. Okay, plus 100 into 30 divided by 100. Okay, that is true, right? So if I solve this, how much I'll get? I'll get W, which is equal to 210.5. Okay, if I solve these two equations, let's say this is equation 1 and this is equation 2, I'll get W is 210, and if I'll also get F is equal to 310.5. So now I'll get the two values. I'll get this value and I'll get this value, but it doesn't stop here. They have also asked one more question, that how much of they are asking this value also. See, they are asking for the value of B and R also. So how to calculate this B and R? See, we don't need to calculate for overall value. This is the overall value and we have already find it out. But if some case, if they wanted to calculate this value and how to do it, then we have to cut the equation, just like we did it before. Cut the equation here. Okay, so just focus on this part. So in this part, as you can see, cut this equation, and in this part, as you can see from here, as you can see, F is given. Okay, F is given. Along with that, R is also coming because of here. And what I'm getting is, I'm getting B and W. So I'm just looking this part. Okay, F plus R is equal to B plus W. Am I right? These are like going outside and these are coming inside. Okay, let's do the mass balance for this. 0.1 plus R is actually what is R? Is 2. Okay, so which means R is actually 2 divided by 100 into R, which is equal to B, which is B is actually, we don't know that also, 25 divided by 100 plus W. W is actually, we know it's actually 210.5 into 0.5 divided by 100. So this is the base. And first equation, if we can just apply the values, for example, F, we know that it's 310.5 plus R we don't know, and B we don't know, and this is 210.5. This is equation number 2. This is equation number 1. Solve this equation, you will get R and B. R is actually 21.7. B is actually it's actually 100 plus this 21.73, right? So it might go 121.73 or something. So that's it. I'll get R and B values as well, and F and W values as well, and P also I know already, it's 100 kg. So all the questions has been answered. So that's how simply we can easily calculate the systems if it has a mass balance. Now in the next class, we are going to talk about the energy balance, which is a little bit tougher from this syllabus. See, all this question which I am asking right now is probability of asking this question in the patent exam is very much higher, because all the question has been asked previously in a single book called R. Paul Singh, which I have already mentioned in the video of how to prepare the CGPM examination, right? So in the patent examination like discussion video, I've already mentioned the book called Art Pulsing. From that same book itself, they have asked two questions, and both of the question is asked in this single chapter, which is first chapter. They haven't even gone to the second chapter. The question is asked from the first chapter itself. So if you have studied well the first chapters, the question might come in the chapter as well. So that's why I am focusing all the question in the first chapter and trying to explain you in the best way possible. So I hope you like this video. So let's see you in the next class, where I'm going to teach you about the energy balance.